Hey there, if you are studying for the digital SAT, you already know Desmos is a cheat code. But what happens when the college board actively tries to set a Desmos trap? Welcome back to Bhargav Academy. Today we are putting Algebra and Desmos head to head on 5 brutal non-linear SAT questions. I am going to show you how to solve them using the calculator. But more importantly, I'll show you the 10-second algebraic shortcuts that will actually save your score when Desmos gets too messy. Let's lock in and speedrun question 21. So let's read the question. 36x square plus bx plus 49 equal to 0. In the given equation, b is a constant. For which of the following values of b will the equation have more than one real solution? So more than one real solution. And he's asking you to find the value of b. So let's first do it the algebraic way and then I'll show you the Desmos way. So if it is more than one real solution, we should have discriminant should be greater than 0. So b square minus 4ac should be greater than 0. b is b, a is 36 and c is 49. So this comes down to 4 into 36 into 49. Now whenever you have in algebra an expression which says b square is greater than 49, for example, then the answer comes out to be b should be greater than 7 or b should be less than minus 7. So apply the same situation over here. B should be greater than, since all three of them are perfect squares, I can write it down 2 into 6 into 7, and b should be less than minus of 2 into 6 into 7. So that comes out to be b should be greater than 6 ones of 48, am I right? 6 to the 12, 12 into 7, 7 to the 14, 84, yes. B should be greater than 84 or b should be less than minus 85. Alright, so these are the two options I should be looking for. B should be greater than 84. Is there any number greater than 84? No. B should be less than 84. Sorry, b should be less than 84. So is there any number which is less than 84? Yes, I have a number which is less than 84, minus 84, which is minus 85. Alright, let's do the same problem using Desmos. In the Desmos, 36x square plus bx plus 49. Add a slider, and whenever there is a slider, change the values from minus 100 to plus 100 so that you have lots of free space to look around. Now, where is our graph? Is it sitting somewhere? Yes, it is there. So what I should be looking for in Desmos? More than one real solution. So I'm expecting the graph to cut the x-axis at two different points. So let me see where that actually happens. It is happening here. So for 90, it is happening. Imagine doing this problem using only the Desmos. So at exactly b equal to 84, it is touching the x-axis. So if the question was find for only one solution, then b equal to 84 would be the answer. But he is asking you to find for more than one real solution. So it should be greater than 84. But here if you see, there are no options which are greater than 84. So we should immediately not panic. Go for the negative side of b and check where this is happening again. So that's the reason why b, always take it from minus 100 to 100. You can move it even further if required. Again, if you see here, minus 84, you have at b equal to minus 84 as well, you have exactly one solution. If anything less than minus 84, then you have b value. You have more than one real solution. So b less than minus 85, as you can see, gives you more than one real solution. So you have done using both the calculator and the algebraic way, and I would say Desmos here is the clear winner because it's much faster. The only catch here is if you don't get the answer using the positive way, positive side, then also check the negative side and take the b value minus 100 to 100. Usually minus 100 to 100 is suffice. If required, you can go for more. You can expand the value of b. Let's go to the next question. Y equal to minus 3.5 and y equal to x square plus 6x plus k. In the given system of equations, k is a positive integer. K is a positive integer, so let me write it down. K belongs to positive integer. Positive integer. The system has no real solution. Understand, the system has no real solutions. What is the least possible value of k? Least possible value of k. So first let me do it the algebraic way and see how much time it's taking for me. So y equal to minus 3.5, I'll substitute that here. So minus 3.5 is equal to x square plus 6x plus k, and x square plus 6x plus k plus 3.5 equal to 0. From here it has no real solutions, so discriminant should be less than 0. So b square minus 4ac should be less than 0. b is 6, coefficient of x, a is 1, c is all of this, k plus 3.5. So 36 minus 4 into k plus 3.5 should be less than 0. 36 should be less than 4 into k plus 3.5. I can cancel this out. Sorry, this is 9. So 9 should be, so from here if I calculate the value of k, it comes out to be 9 minus 3.5. So k should be 5.5. Am I right? Alright. Now let's do this in the Desmos and see how much time it will take there. So let me go to Desmos. Alright. Please be with me here. You will be learning some new things over here. Y equal to minus 3.5, substitute that. Y is equal to x square plus 6x plus k. So once again the question is, k is a positive integer constant. Okay, the system has no real solutions. All right, what is the least possible value of k? What is the least possible value of k? Let us add a slider to k, and then once again 100. This is minus 100. Now let's see what's happening. So the system should not have any real solutions. Both these two equations, both this and this should not have any real solutions. So these two should not meet anywhere. So if these two should not meet anywhere, y equal to minus 3.5 is this line, and the quadratic is, as you can see here, this should not meet. So let me move the value of k so that they are not meeting. Okay, they are not meeting. Remember, k is positive integer, so we should only check for k values. So k equal to 6 is okay, they are not meeting. What about k equal to 5? K equal to 5 they are meeting, since he has already mentioned to you that k is a positive integer. So k equal to 6 is the answer for us. So k equal to 6 from Desmos. K equal to 6, and from here k is greater than 5.5. K is a positive integer, so k should be equal to 6. The next positive integer after 5.5 is 6. So k equal to 6. Here also Desmos clearly wins. Desmos is the faster way. Here in method 2 is Desmos, and I would say here Desmos is much better way to do this problem. Let's go to the next problem. Now x times kx minus 40 equal to negative 25. In the given equation, k is an integer. k is an integer constant. Okay, if the equation has no real solution, so that means d should be less than 0. K belongs to integers. What is the least possible value of k? So he's asking you to find the value of k. First of all, let's do it the algebraic way and then we'll go to the calculator. Let me expand this. Kx square minus 40x equal to minus 25. Kx square minus 40x plus 25 equal to 0. Discriminant should be less than 0. So b square minus 4ac should be less than 0. b is minus 40. Coefficient of x. A is k. C is 25 plus 25. So that comes out to be 40 square is 1600 minus 100k should be less than 0. Alright, 1600 should be less than 100k. So from here I can write it down like this. From here I can write k should be greater than 1600 by 100. If I cancel this out, k should be greater than 16. And what is it telling you? K is an integer constant. So k is an integer. What is the least possible value of k? The least possible value of k is the next integer after 16. So k should be equal to 17. So this we have done using the algebra. Now let's do the same stuff using Desmos. This is method 1 using algebra and method 2 we'll do using Desmos. Let's go. So let me substitute this equation as it is and see what is going to come over here. So I want to erase the previous memories of k, if there are any. Yes, I have done it successfully so that it doesn't interfere with the existing answer. Minus 40 should be equal to minus 25. Do we see anything here? Okay, I don't see anything here, but don't panic. If you get into this kind of a situation, then expand this a little bit as we have done in the algebraic way. So let me write it down like this. K x square minus 40x equal to minus 25. Is something happening now? Still not happening. Still don't panic. Then bring this minus 25 over the left hand side. So that comes out to be plus 25. Now see if there is anything happening. Add a slider. Then something will happen. Now what is the condition is telling you? If the equation has no real solution. The equation has no real solution. So let's move the value of k so that there are no real solutions. Still again, always just put this minus 100 to 100. That makes our life easier so that we have a lot more ground to cover. You can play around with the value of k. No real solution. So this is no real solution situation. The graph should not be touching or intersecting the x-axis. So where is it happening? He's asking you the least possible value of k. So k equal to 16, it is touching the x-axis. So k greater than 16, he has already mentioned to you that k should be integer constant. So k greater than 16 is answers that ends up with k equal to 17. So with Desmos it is much more faster and we are getting the answer as, okay, wait a second, what did we do? What is the value of k here? Yeah, k equal to 17 is the answer. Yes. Using the Desmos, here also Desmos is much faster. From here we have got k equal to 17. Now let's go to the next problem. Alright, once again, let's look at the problem. 10x plus y equal to minus 20. So this is a linear equation. 2x square equal to y plus 120. Here we have combination of, here we have our nonlinear equation. The graphs of the equations in the given system of equations intersect at the point x comma y. So he wants both the graphs to be intersected. Okay, good. What is the possible value of x? He's asking you the possible value of x. So first let's solve this algebraically and see how it goes. So here I am seeing a y here. So from equation 1, I'll try to find the value of y, which comes out to be minus 10x minus 20 from equation 1. And now I'll substitute the value of y in this equation. So that comes out to be 2x square equal to minus 10x minus 20 plus 120. So that is minus 10x minus 20 plus 120. So 2x square is equal to minus 10x plus 100. 2x square plus 10x minus 100 gives me 0. From here I can reduce this equation to this. Now what is the condition he has told you? What is the possible value of x? He's asking you the possible value of x. So that's the reason why we have eliminated y from these two equations, from equation 1 and 2. Now from here I want to find the value of, I need to factorize this to get the values of x. So how am I going to do it? I need to split this middle term. So to split the middle term, what is the procedure? If I add two numbers, I should be getting the coefficient of x, which is plus 5 here. And if I multiply any two numbers, I should be getting minus 50, which is the constant term. So I have to find these two middle terms. So that comes out to be, what does it come out to be? 10 into minus 5 will give me minus 50, and 10, and if I add 10 and minus 5, I'll be getting plus 5. So I can split this middle term like this middle term, x square plus 10x minus 5x minus 50 equal to 0. I can factorize this in this way. So that comes out to be x minus 5 into x plus 10. So the possible values of x are x equal to plus 5 and x equal to minus 10. Let me see if there are any. X equal to plus 5, it's not there. X equal to minus 10 is there. Okay, now let's try to do this problem in Desmos and see how fast we can solve this. Let's see what will happen in Desmos. First of all, let me erase any memories, past memories. Now let's go for a present set of equations. 10x plus y is equal to minus 20, and then what is the other equation? 2x square equal to y plus 120. So these are the two equations, and the question is what? They intersect. So he wants them to intersect and see, let's see if they're actually intersecting or not. So these 2 points, they are intersecting. What is this other point? Yes, this is one point which is minus 10 comma 80. So let me write it down here. Minus 10 comma 80 is one point. What is the other point they are intersecting? 5 comma minus 70. So the two x values are minus 10 and plus 5 from Desmos. Minus 10 I can see it here. Plus 5 there is nowhere. So B is the answer. Here also Desmos wins clearly. It is much more faster. So very nice. So let's go to the last problem. Now here we go. In this problem, Desmos clearly fails. Please don't do this with Desmos. It's going to take away a lot of your precious time during the exam. Let's solve it algebraically. It's really faster. Even in algebra, I'll show you two methods and you decide which one is apt for you, which one is faster for you. So this is method 1. Now let's read the question. 10 by x minus 3 by y equal to minus 3 by z. The given equation relates the variables x, y and z. Great. Where x is greater than 0, y is greater than 0, and note this point here, z is greater than y. Which expression is equivalent to x? So he's asking you, basically he wants some expression here, x equal to, what is this expression he's asking you? Okay, let me write down this equation once again. 10 by x minus 3 by y is equal to minus 3 by z. Since I want to find the value of x, I want to keep only the x terms on the left hand side and rest of the terms on the right hand side. I can reduce this equation like this. 3z minus 3y is equal to 10 by x. So 10 by x is equal to, let me flip this numerator and denominator. So from here I can calculate the value of x. It comes out to be 10yz by 3z minus 3y. So this is the value of x. Does it match any option? Yes, it does. This is the answer. Now let me show you the other way. Method 2. Method 2 is I just need to make sure that, look at this equation. I'll write this equation again. 10 by x minus 3 by y is equal to minus 3 by z. Okay, now z is greater than y. He's asking me to find the value of x. So what I'm going to do is, I will substitute, say, y equal to 3 and z equal to, because z is greater than y, I'll substitute this as 6. Why did I choose 3? Because 3 by 3 will give me 1. And why did I choose xz equal to 6? Because 3 by 6 again it will reduce to 1 by 2. So let me write down this equation now, and after substituting these values, 10 by x minus 3 by 3 is equal to minus 3 by 6. So that comes out to be 10 by x minus 1 is equal to minus half. From here I can find the value of x. 10 by x equal to 1 minus 1 by 2. So 10 by x is equal to 1 by 2, and from here I can solve x equal to 20. Now I have to substitute y equal to 3 and z equal to 6 into all these options and check where I am getting x equal to 20. So that's what I should do. So let me substitute 10 into y is 3, z is 6. This is definitely not 20, so this is not the answer. Z minus y, 6 minus 3 by 10 into y is 3, z is 6. So 3 by 10 into 3 into 6, this is definitely not 20, so this is also not the right answer. Let me check for option C. 10 into y is 3, z is 6 by 3 into z. 3 into z is 6 minus 3 into 3. So this comes out to be 10 into 3 into 6 by 18 minus 9. 10 into 3 into 6 by 9. Am I right? Am I doing it correctly? Z is 6 minus 3 is 3. 3. Okay. 3 3s are, 3 2s are. So this comes out to be 20. Alright. So this one matches. Alright, so I've shown you two methods. Either you can substitute, give some values to y and z and find out the value of x and check with all the options whichever is matching, or you can directly do it in the method 1. So let's quickly summarize how did we do these problems. We have first solved this problem using both algebraic way and Desmos way, and we have seen that Desmos is much more faster, given that you have understood that if you are not getting on the positive side, then you should also be checking on the negative side so that our answer matches for the Desmos. And then this problem again we have seen that Desmos is much faster way than the algebra. For this problem as well, we have seen that Desmos is much more faster. I have shown you how than the algebraic way. Here as well, Desmos is way faster than the algebra. But in this last problem, you can't do it on Desmos. It's not that you can't do it, but it's going to take you a lot of time and you're going to lose it. So I'm not telling you how to do it on Desmos. It is simply a waste of time for you. You should do that. I would really suggest you to do it with algebra. So you can choose any of the methods which are shown below, and whatever is convenient to you can do. So there we come to the end of this video. I hope you have learned something useful. I thoroughly enjoyed making this video, and let me know how did you enjoy. And that is how you crush nonlinear equations. So let's settle the debate. Which method actually won today? Drop a comment below and tell me if you are team algebra or team Desmos for these question types. But listen carefully, just watching me speedrun this won't build your muscle memory for test day. You have to do the heavy lifting yourself. Go to the pinned comment right now, download the blank PDF with this exact 5 problems and try to beat my time using my class notes to check your work again. So thank you so much. Hit subscribe so you don't miss out our next 15-minute masterclass, and I'll see you in the next video. Keep practicing. See you again.